Okay, I just wanted to walk through another one of these examples so that you could have another practice to work from in order to prepare for our quiz. I told you I like these problems because it incorporates a few different skills that you're going to apply in future mathematics. So the goal is to take an expression, a sinusoid 5 sine of x minus of 12 cosine of x, and rewrite it in the form of a sine bx plus c. So this is just a sinusoid that's been shifted horizontally. It's got a different period to it, and it's got an a value that would give it its vertical stretch. Now, we did 43 on the note sheet. I figured I would do 44 for you, and then if you want to practice, you could do 45 and 46 on your own, and I can post the solutions for those. Just the numeric solutions, not all the work. So that you can make sure that you're ready to go if you get one of these, which you will on your upcoming quiz. So, first thing we're going to do, as I suggest on the note sheet, is rather than attack this expression and try to rewrite it as this, we're actually going to take this expression and kind of make it look a little bit more like this. So let's leave our goal here of being, we're shooting for y equals 5 sine of x minus 12 cosine of x. And in this example, we're trying to write it as a sine of the quantity bx plus c. So what I'm going to do is take that quantity, y equals a sine of bx plus c, and consider this the sum of two angles, sine of a sum, the sine of the angle bx plus the angle c. So applying the sine of a sum, we're going to get a times the quantity, and now we're going to apply the sine of the sum. Sine of the first angle, which is bx, cosine of the second, plus sine of the second angle times the cosine of the first, bx. Now, notice our variable. Our variable is x. It shows up there and there. The whole part of this is kind of understanding what's changing and what's not. A is a constant, B is a constant, and C is a constant. So if we were to focus on the variable quantity here and the variable quantity here, sine of bx is going to change as x changes, and cosine of bx is going to change as x changes. Let's see what we can do with that. So we're going to distribute this a into this quantity, and we'll take it to the first term and the second term. But I'm going to put the constant terms together in the front. So in this first one, a is constant, and this cosine of c is constant. So I'm going to put those two in the front, and that's getting multiplied by the sine of bx. And then as I bring the a into this second quantity, a is constant, sine of c is constant, and it's being multiplied by the cosine of bx. So what that has now is the potential to recognize that we have a constant times the sine of bx, and we have another constant here times the cosine of bx. And remember our template that we have, that we're shooting for, which is up here. So I'm going to consider this 5, consider that 5 times the sine of 1x, and that expression up at the top, again, this expression is minus 12 times the cosine of 1x. So I tried to color code this so that you can start to see the parallels that we have here. Maybe I should put y equals in front. So this is what we were given, and we were trying to write it like this. So what we did was we re-expressed this sine of a sum this way, and now we can start to match things up. In blue, a cosine c is a constant that must be equal to 5. A sine c is a constant that must be equal to negative 12. And the sine of bx must be the sine of 1x, and the cosine of bx must be the cosine of 1x. So b must be 1. So we can go over here and make a little note of that. B is 1. So as soon as we find go. We'll have A, B, and C, and then we can rewrite this expression with the values for A, B, and C put in, or substitute in. All right, so now equating these blue terms, A cosine of C must equal 5, and A times the sine of C must equal negative 12. So, a couple ways we can do this. I mentioned this when we did it in class. Kind of the slick way to do it is to square these quantities and add them together. So in other words, if I square this quantity and add it to this quantity squared, let's see what I get. A cosine C, which I know to be 5, and A sine C, which I know to be negative 12. If I square these quantities, I should get the same result. A cosine C is the same as 5, and A sine C is the same as negative 12. So if I add those two equivalent things together with these two equivalent things together, I should get the same quantity. So let's square them and see what we get. Let's square this, square that, square this, and square this. I think you can see our lower term here, this guy, is going to be 25 plus 144, which of course is 169. You may notice that as 13 squared. Now in the upper expression here, this one, when we square A cosine C, we're going to get A squared cosine of C squared, and then we're going to add A sine C when it's squared, which will be A squared sine C squared. Now, that must equal 169, because 5 squared, which is equal to this, and negative 12 squared, which is equal to that, equals 169. So you might recognize this more after doing all of our identity work, but when you have a sine squared and a cosine squared, that's always a good thing. Notice a common factor of A squared here. So if I take that expression and factor out that common factor of A squared, I get cosine squared of C plus the sine squared of C. And of course, you should certainly recognize that sine squared plus cosine squared, regardless of whatever the angle is always going to be 1. So essentially we have A squared equals, well, A squared times 1, which is A squared, equals 169. That means that A has to be plus or minus 13. And we can make a choice on that, whether we're going to use positive or negative 13 in a moment. However, let's take a look at what we still have remaining. We now know, let's say that A is either plus or minus 13. And lastly, we need to find out what C is. Put C equals question mark. Well, if you go back to our equation here, we have a couple of places. We have this expression and this expression. So if we choose the positive value for A, then we can, rather than having A equals plus or minus 13, just say A equals positive 13. Now, that will allow us to solve for C. So one of the things I can do is go back and say, all right, A from our first equation over here, A cosine C has to equal 5, and A sine C has to equal negative 12. Looking at the ratio of those two things, because I know sine over cosine equals tangent, so I could take, I could put in 13s for both of them, first of all. So 13 cosine C equals 5, and 13 sine C equals negative 12. We can now say, okay, the cosine C equals 5/13, and the sine of C equals negative 12/13. So with that in mind, you say, okay, let's remember our circle and think about where this could be true. If we had a cosine that was positive, that means we need to be on the right side because cosine goes with x. But if we have a sine that's negative, that means we must be down here in the fourth quadrant. So our triangle would look something like this, where the adjacent side would be here's our reference angle, call that theta r. We'd have a 5 and a 13, and then this third side is 12, but it would have to be negative. So that's the only way this thing could happen. Our angle C must be the angle that got us there. So if we thought about just leaving in this in terms of inverse sine or inverse cosine, if we said C equals the inverse cosine of 5/13, if you think about that, remember inverse cosine would find an angle on the top part of the circle. It would use the first quadrant for positive cosines and the second quadrant for negative cosines. Well, we can't be in the first quadrant, so we can't let C be equivalent to that expression because that would send us to the wrong quadrant. However, if we let C be the inverse sine of negative 12/13, you should remember that inverse sine uses quadrants 1 and 4. So it would give us this angle. It would say, let's say this angle is, I don't know, 70 degrees, so it would be negative 70 degrees. So inverse sine of negative 12/13 might kick out negative 70 degrees. We could go get a number for that off the calculator, but on this quiz, you're not going to have a calculator, so I would ask you just to leave it in terms of that. So we can now say that we've established our B value, our A value, and a C value. So let's rewrite, as we were asked to do in the very beginning, y equals 5 sine x minus 12 cosine x in terms of y equals A sine bx plus c. So we can come back and say, okay, y equals A is 13, we chose the positive 13, sine of B, which is 1, so I'll go ahead and write it in there. We need an x, and then plus c, where we would just say c is the inverse sine of negative 12/13. And that way we've done it all without a calculator and just left things in terms of inverse sine. However, again, it would be incorrect if we put inverse cosine of 5/13 because that would have given us this angle up here. All right, that ought to do it. Try 45 and 46. You can tell this is a plus here in number 45. This one is going to turn out to be, you're not going to have to make this positive-negative distinction. That'll be pretty straightforward like the one in the note sheet. But 46, you're going to have this issue again with what quadrant we're going to need to be in. So try them. I can post the answers for both of those guys so you can check your answers and go from there. Good luck.